Okay, so yesterday we started talking about the trigonometric functions. We talked about them in relationship to the x and the y and the r, okay, but we also said that you could talk about them in terms of SOHCAHTOA, which is more what we'll focus on Friday, okay? We talked about these, and I said the important ones, like this top one was obviously really confusing, right? But we said the important ones were the Pythagorean identities and the quotient identities. The Pythagorean is the sine squared plus cosine squared equals 1, tangent squared plus 1 equals secant squared, 1 plus cotangent squared equals cosecant squared. And then tangent's the same thing as sine over cosine, and cotangent's the same thing as cosine over sine. That's out this example using triangles. It said find sine and cosine if the tangent of theta is 4/3. It's in the third quadrant. We put an angle in the third quadrant. We did the x, the y, right? We solved that triangle. So what I'm going to show you is, so if you want to like duplicate that page, because I'm going to show you another way to do it. We're going to use the Pythagorean identities to do it, okay? Which is going to be a lot more complicated than the way that we did it yesterday, I'll be very honest. But if the directions say use Pythagorean identities, this is what it means.
On the test, are we going to have to?
We haven't even gotten there, I'll be honest. We haven't even gotten there yet. When we do, I'll let you know. Okay. So the Pythagorean identities, again, are sine squared plus cosine squared equals 1. Tangent squared plus 1 equals secant squared, and 1 plus cotangent squared equals cosecant squared. So for me, like sine and cosine go together naturally. For me, that's an easy one to remember. But then I have to remember that the two c's go together in the Pythagorean identities, and then tangent and secant are the ones that are left by themselves. Okay? You get to write this out on a note, but there is a trick to like figuring these out. So like, I don't know, maybe one day I'll show you, but for right now you can write those on a reference sheet so you don't really need them, okay? Just maybe take a screenshot of that last slide because you'll use it a lot if that helps you, okay? And we're gonna add to those references, but that's what you need for 5-2. So remember the quiz next week is just on 5-2. All right, so having said that, and this says find sine and cosine if tangent of theta is 4/3 and theta is in quadrant 3, use the Pythagorean identities. So I want to go to my Pythagorean identities and find the one that has tangent. So what does that one say? Tangent squared plus 1 equals secant squared. So tangent squared, and really it would be tangent squared theta. I get lazy and don't write the theta every time. Equals, plus 1 equals secant. Not really, if you know that you're going to be plugging in there.
Wait, why is it that one?
Because the only information I have is tangent.
Okay. Wait, what does the little 0 even mean?
It's called theta. It's just the name of an angle.
With an F.
Theta, T-H.
Oh, theta.
Theta, yeah. It's really good college prep because sororities and fraternities use these Greek symbols. So you'll be like, oh, I know that name because of math. All right, so I'm given, the only one I'm given is tangent, so I'm going to grab that one, right? Now, the tangent of theta is 4/3, which means tangent of theta squared would be 4/3 squared. So I'm substituting that in. That plus 1 equals secant squared. So what's 4/3 squared?
16 over 9.
16/9. Plus 1 becomes 16/9 plus 9/9, or 25/9, and that equals secant squared. So if I want to find secant, what do? Square root it. So I would square root both sides, and I'd get 5/3. You with me so far? Mm-hmm. I'd actually get plus or minus 5/3, and this is where the information about it being in the third quadrant is important. That tells me which one to pick. So remember, in the third quadrant, my angle would be here. I'd be moving left, so it's a negative x, down, so it's a negative y. And remember, so sine is y over r, cosine x over r, tangent y over x. Cosecant would be r over y, secant would be r over x, and cotangent would be x over y. So if I'm in the third quadrant and I have a negative x and I have a negative y, is my secant, which is going to be r over x, is my secant going to be positive or is it going to be negative? It's negative. So I'm going to say negative 5/3 equals r over x. So what's the cos, well, or even equals secant. I could just write it like that, right? Secant. So what's the cosine? Negative 3/5. Just flip it. That's the first thing, right?
Wait, why is it negative 5/3?
Like, why is it negative?
Yeah.
Because I'm in the third quadrant. So in the third quadrant, we move left and we move down, which means both the x and the y are going to be negative.
Mm-hmm.
We only use the x for secant, and the radius is always positive. So I keep the negative on the x, which makes it just negative.
Oh, okay.
Does that make sense?
Yeah.
Yeah. So that tells you the location of it, and then the location of it tells you what sign to keep. Okay, so now I've got cosine, right? And I want to get to sine. What Pythagorean identity can I use to get from cosine to sine? Good. Sine squared plus cosine squared equals 1. So sine squared is what I don't know. Again, I'm going to put the theta in there just so I know that the angle's there. Cosine would be negative 3/5. Sine squared theta would, plus 9/25 would equal 1. Sine squared theta would equal 1 minus 9/25. This is 25/25. Sine squared theta would equal 16/25. So sine of theta plus or minus the square root of 16/25, which is 4/5. Now it's plus or minus, right? So look in my third quadrant. My y is negative. Sine is y over r. R is always positive. So I'm going to pick the negative one.
So if this was tangent, because it's tangent in the third quadrant, it's positive 1.
So in the third quadrant, tangent would be positive. Yeah, right.
So is this just like a super complicated way to do
I mean,
it?
yeah.
Same thing we just
Yeah. For me, the triangle is obviously super easy. I just want to teach you both ways in case you see that where the directions say use the Pythagorean identity to do it.
So couldn't you have just done the Pythagorean triples?
Yep.
Got it.
Okay, so let's do one more.
Are they always going to be Pythagorean triples?
No.
So if it's not a Pythagorean triple, you do this?
Mm-mm.
Or a
If it's not a yeah, you could use the Pythagorean theorem. Yeah. Only if it says use, like what the directions here said, use Pythagorean identities, are we stuck with this method. If it just said to find it, you get to choose, and I would obviously recommend the triangle. All right, so cosecant of theta if I have cotangent. So which of these uses cosecant and cotangent? 1 plus cotangent. So 1 plus cotangent squared theta equals cosecant squared theta. This time, I got lucky because it's exactly what I need, right? 1 plus cotangent, negative 1/2 squared, would equal cosecant squared. 1 plus 1/4 equals cosecant squared. This is 4/4. 5/4 equals cosecant squared. So cosecant would equal plus or minus the square root of 5 over the square root of 4, which is 2. Now we're in the fourth quadrant where my x is positive, my y is negative, which means my cosecant is going to be what? Cosecant involves your sine, right? Cosecant would be r over y. It's the negative one. is cosecant of theta, not just theta. God bless you. So I'm going to teach you a trick that, I mean, it's important to understand that, but I'm going to teach you a kind of a shortcut for knowing the signs. And this, again, will come back when we do like the unit circle, but I think it's so helpful that I'm not holding it out. So in my quadrants, in quadrant, we've got quadrant 1, we've got quadrant 2, we've got quadrant 3, and we've got quadrant 4. In the first quadrant, everything is positive because I move right and up. In the second quadrant, I'm moving left, okay, and up, which means my cosine is negative, and that means my secant is negative. All others are positive. In my third quadrant, I'm moving left and down, so both the sine, its reciprocal function, which would be cosecant, the cosine, and its reciprocal function, which is secant, all that's negative. Tangent and cotangent are the only positives. In the fourth quadrant, you move right and down. So cosine, positive. Actually, let me start with what's negative because I did it the same way every other time. So I'm going to the right and down, which means sine is negative, cosecant is negative, tangent is negative because only one of them is negative, cotangent is negative, cosine and secant are the only ones positive. If you want to wait, I'm going to add one more thing on there. The acronym that can help you with this is all students take calculus. So if you start in the top right and you work your way around, all students take calculus. Tell you which of the original 3 trig functions are positive. So the A is for all, right? But in the second quadrant, S stands for sine. You have to know if sine's positive, then its reciprocal function, which is cosecant, is also positive. So these are just for sine, cosine, tangent, and then you have to apply the reciprocal. So again, that's just based on your original 3 trig functions, okay? Not the reciprocal ones.
So whatever the charge of the original trig function is,
It's going to be the same.
It's going to be the same.
Yep. Yep. This just stands for sine, this just stands for tangent, and this just stands for cosine. Those are what are positive. But then whatever they are, they're reciprocal. Wait for it.
Except for in the second quadrant.
I wrote something there like. So if it's sine, it's also cosecant. If it's tangent, it's also cotangent. If it's cosine, it's also secant. Those are what are positive.
And the second quadrant is tangent also negative.
Yep, because you move left. You go up, but you move left. So your x is negative. Right? Because tangent's y over x. So if one of them is negative, then tangent's negative. So in the second quadrant, we go left, but we go up. So we've got a negative, but we've got a positive. Third quadrant, we go left and down. So you've got a negative and a negative. Does that make sense? All right, next set of examples. Wait for it to catch up. Why are you moving so slow? This one kind of goes back to the one we did before with our coordinate point. It says find the value of the 6 trig functions of an angle in standard position running from -4, 0. Now think about what's happening here. If I go -4, 0, I'm going left 1, 2, 3, 4, 0. Can I make a right triangle from that?
No.
If it's on the axis, you can't make a right triangle from it. Does that make sense? Which means I have to just basically use my x, my y, and my r, which if this is my center and this is my end point, what's the r? How far out did I go? 4. So my r is 4. This is obviously my x. This is obviously my y. So then I get sine which is y over r cosine,
Make the right triangle.
because it's directly out. I didn't go up or down any to make the angle. This is the only part of that I have.
Oh, so when you're making the triangle,
You have to have an
the
angle of some.
lines of the graph already count as a line.
Correct.
So wherever you put the point,
You're going to use your horizontal distance and your vertical distance to make that. So then tan y over x, and then we're going to flip them to get the reciprocals, right? What's so funny? So what is y over r? What's the y? 0. What's the r? 4. What's 0 over 4? 0. Oh, that's really hard to read. Sorry. Cosine is x over r. The x was negative 4. The r is 4, negative 1. The tangent is the y, which is the 0, over the negative 4, which is 0. And then we just flip them. So what happens when I flip 0? Undefined. What happens when I flip negative 1? Negative 1. What happens when I flip 0? Undefined. Okay, this one says simplify 3 secant 180 minus 5 tangent 360. So we have to go back to those angles, right? So the 180 is here on the left-hand side. That was 180 degrees. Do you remember the coordinate point that was there? How far out do I go on my normal unit circle? 1. So this would be negative 1, 0. And then I need the angle 360. 360 is on the right-hand side where 0 is. So what would that coordinate point be? 1, 0. So what would be the secant at 180? I'd have to do 1 over the cosine, right? So what's cosine? Because it's the reciprocal of secant. So I can find the cosine and then just flip it. You could either do r over x, or you could find cosine and then flip it. You could do it either way. So what would be the radius at 180? 1. What's the x at 180? Negative 1. So what's the secant at 180? Negative 1. So I do 3 times negative 1 minus 5. Now I want the tangent at 360. The tangent is y over x. What's the y at 360? 0. What's the x at 360? 1. So what's the tangent there? 0. 5 times 0. So negative 3 minus 0 is negative 3. Yep. So when you see actual values in the place of where we normally see thetas, you're looking for a value there. You're going to use that angle to find the exact value.
Wait, why did we need to write 1 over cosine?
We didn't. I said you could either do 1 over cosine or you could do r over x. You could do either one. All right, now I've got tangent at 360, which we just said was what?
1, 0.
Well, what was the tangent there? That is the coordinate point there, but what's the tangent there?
Y over
0. 4, what's the sine at 180? So we're back over here. The sine would be y over r. Y is 0, right? R is 1. What's the sine there? 0.
where'd you get the 0, the first 0?
The tan at 360 is the same thing we found up here. The y over x from there. Plus 2, and then it's cosine squared of 180. So what's weird is that the squared is here. That means take the cosine and square it. So the first thing we're going to do is find the cosine. So at 180, which is back over here, what's the cosine there? So it's x over r. Negative 1 over 1, which is negative 1. And then I square it. So even though the squared comes before the angle, that's what we do. We take the cosine and then we square it. So I get 0 plus 4 times 0 is 0. Plus, I don't know why I wrote that twice. That shouldn't be written twice. 2 times negative 1 squared. 2 times 1, and that just ends up being 2. So when there's actual values next to your trig functions, you want to set up your circle, okay? You want to use whatever quadrant angle. So remember, if I needed to use 90 or 370, these quadrant angles, unless otherwise given points, are 1, 0, 0, 1, negative 1, 0, and 0, negative 1. This is 0 and also 360 degrees. This is 180 degrees. Nope, sorry, that's 90 degrees. This is 180 degrees, and this is 270 degrees. So those are your quadrant angles, and those you'll see again. Questions on what we talked about today? So tomorrow we'll do a little bit more extra practice. Tomorrow I'll have more information about your quiz. So remember, quiz is just going to be this section. And then Friday we'll move into the right triangle trig, which for me is a lot easier. Like, there are people whose brains work with this, and there are people who's worked with the right triangle or the unit circle. That to me is easier. Yeah. Yeah, so if you already submitted last night's part, just resubmit the full thing. If you didn't submit last night, it's okay, just resubmit the whole thing. Okay? So it's the same assignment. I moved it, but I didn't move it until late last night and I forgot. Helen, your quiz is Tuesday. Hang on. Didn't print my calendar. Quiz is Wednesday of next week.
On which section?
Just 5-2. So what we learned up till today.
Okay.
So we'll review it tomorrow. And then we'll do 5-3, which is right triangle trig, but that won't be on the quiz. We'll save that for the test, which is not till the week after that.
Is 5-1 on the quiz?
Nope, just 5-2. 5-1 is so much of like memorization that it doesn't really, we have to, we're trying to be creative in the way in which we normally quiz on this would be very different, but so much of it is like memorization that it's hard.